All right. So we are back. And let's see. So some are good. I'm glad I was following your meeting chat. I was following you guys helping each other out. So that was really great. So what I want, as some of you saw, that last one was a bit tricky, right? So let's, what we can do is, what I'm going to do is, I'm going to show you with my IDE, with JGrasp, how we can take these values, put them in to what's called interactions. And instead of having to write whole programs for simple like questions like this, what we can do is we can stop sharing. Where are you? Let's see. I want to share my whole screen now. Okay. And so what we can do is we can take a look at, before we get into some of these examples here. So this interactions tab, for those of you who have JGrasp, is I can write some simple things in here. So let's say I might say I want to create an integer, call it x. I want to give it a value of 10. Okay. Now, see what happens up here is it shows me some of these things that I'm creating. So let's double y equals 10. Okay, let's check my variables up here. Okay, now if I wanted to just see what some value is, let's say I wanted to say what is x times y. Now if I put a semicolon on the end, it's not going to do anything. Okay, it's not a statement. But if I don't put a semicolon on the end, it'll just put it out to the screen. It's the same as if I had done system.out.println. Same as if I had done that. Okay. All right. So the reason I want to get into this is, one, is I want to go back to something where I talked about this single versus double ampersand. Okay. Because I want to show you what happens in these two. So let's say I want to say x is greater than 10 and x plus plus is less than 20. Okay. What's going to happen? This is going to get evaluated. It's going to be determined to be false. So we shouldn't have to evaluate this side. Right? False. X is greater than 10 and x plus plus is less than 20. That's false. Notice also here, we can see x here. It didn't change values. But if we do a single ampersand, okay, what's going to happen? We're still going to get false, but notice that the value for x changed. Okay, it's red because it's showing that it changed something. And if we see this, okay, x is 11. Now, the reason why this is because double ampersand, we only evaluate until we know what the result of this is going to be. If this is false, we don't even bother with the second half. But in the single ampersand, if this is false, we still do the second half. Okay, so that's a little bit important for you to understand the difference between those two. They can be useful in some interesting situations like this, especially if they're, as we get into it later, if there's a method call on this side and a method call on this side, and we want them both to be executed no matter what, then we can use this the single ampersand to do that. Okay. Is there a question? Okay, you're still good. Yeah. That brings me to the other thing I want to do with this interactions thing. What you can do is we can take this and we can copy this. Okay. Copy, go back here, paste, Okay, so notice this is my line. Now, when I hit enter, if I don't put a semicolon on there, like I'll put a semicolon, it's going to give me a problem. But if I don't put a semicolon on there, saying, okay, what would be the result if I were to display this? And the result is true. Hopefully you guys all got this one. I think you all got this one. 1 plus 2 plus 3 plus 4 is 10. 1 times 2 times 3 times 4 is 6 times 4 is 24. And so this would be 24 is greater than 10. 10 is less than 24, so true. All right, that was an easy one, easy warm-up one. Okay, this one gets a little bit harder, a little bit trickier. See, it's false. All right, 1 plus 6 is 7. 7 divided by 7 is 1. 1, oh, we got to do the division first. But hopefully you caught that this was integer division. 6 divided by 7 is 0 in integer division, so 1 plus. So these are, it's not that this is less than this, it's that they're actually equal. So if I were to say, is it less than, I would also get false. If I were to say, is it equal to, then I would get true. Right? Okay, so be on the lookout for that, because if I change that one symbol, some of you might have gotten this one wrong. All right. Okay. Now here's going to be an interesting one. We're getting more and more interesting with each one. Okay. So if we calculate it, 3 times 4 is 12. 6 divided by 4, integer division is 1. So 12 plus 1 minus 1 should be 12. Okay. Same thing here. 3 times 4 is 12. 6 divided by 4 is 1. 3 times 4 plus 1 minus 1 should be 12 also. Now the reason why this one's a little bit trickier is because some of you might have thought that because the double number was here, therefore it would have made this into double division. But that's not true. This, because the division is done first, this double number does not impact this type of division. It still stays integer division. So let's see if they're equal. Where am I missing something? Comma or end of interactions at before 6. I wonder if it grabbed a character of some kind. I wonder if it grabbed a character of some kind from PowerPoint that I'm expecting. All right, I'll have to take a look at this one. 3 times 4 plus 1, 6 divided by. That's right. Oh, it's this minus sign. Windows reform. My PowerPoint reformatted my minus sign. Okay. I knew that wasn't anything. All right. See, this is what happens when you go between programs, I guess. Oh, okay. So it says that they are true. Now, in a sense, is a little bit problematic. And the reason why, and I think one of you asked the question or something. Okay, yeah. I think this is a little bit problematic, and here's why. Now, the result of this side, like I said, this double number does not impact this division, but it still impacts this expression. So let me show you what I mean by that. So if I were to take this, give you 12, and if I were to take this, 12.0. Now, yes, the value-wise, those are equal, okay? But it can cause problems. I hope you guys remember we talked about this last week, that if I had like the double Z, these are bad naming conventions, by the way, so don't use these, okay? So now if I were to do Z minus equals 0.5, okay. Oh wait, it's the 0.1 is what we did. Hold on. If I were to do Z minus equals 0.1. Notice what happened there. You would expect 0.7, but it actually got to be this weird thing out here, right? So if I were to say, does Z equal 0.7, is that true or false? Hopefully many of you said false. It's not equal to 0.7. It's actually equal to 0.700000001, right? So here, let's go back to this example back here. 12.0 and 12 and 12, they're not, they're equal, but man, that's dangerous. Oh, that's dangerous. What would have happened if this, because of whatever reason, through calculations, it would have given me 12.0000, 10 zeros and a 1. And I would have said, does that equal 12? And the answer would have been false. It would have given me false, right? Same way as it did down here, where Z equals 0.07. Sorry, it's 0.7. Because what did I do? I started with 1.0. I subtracted 0.1 off of it 3 times, and I get what I think should be 0.7, but it's not quite. Okay. I hope that clears up. I hope you guys understand why it gave me that false answer. So if I do this, notice it's still going, right? It's still, now it should be 0.6, but it's not. Now it should be 0.5, but it's not. It should be 0.4, but it's not. All right, and notice the more we go, the more off it gets. All right, notice it's still getting off again. Right. Now, you would expect this to be 0 at this point. I've taken 1.0, I've subtracted 0.1 off of it 10 times. You would expect it to be 0. It's actually this weird number here. It's basically, it's so small that it's like 10 to the minus 16th, right? This is a scientific notation. So this is 1.38, blah, 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 times 10 to the minus 16th power. Practically 0, but does it equal 0? No, it does not. Okay. I'll talk, not this week, but in a future week, I'll talk with a way to test for double numbers, because we would like for this to be true, right? We would like to say, if we take 1.0 and we subtract 0.1 off of it 10 times, we would like for the answer to be that it is 0, that we could run this through an if statement and get an expected correct output. All right, so I'll show you how to do that in a future class. Okay, we won't make that as part of today's lesson. All right, let's go back to here. Let's look at our few examples. Okay, unless we have time for. So we have just a simple if demo. So we compile it. I'm gonna check and see if there's any questions. Right. Okay. So here what we're going to do is we're going to get an integer from a user, and if it's divisible by 5, we will print them a message. If it's divisible by 2, if it's even, we will present them with a message. Okay. So if we run it, enter an integer, let's give us one that's divisible by both. Okay, 20, for example. There it is. Okay, both of them got displayed. Because this isn't part of an else, okay? This is an if statement, do something. We're done with that if statement. Now, if it's also this, do this. Okay? So if we run it again, we give it a different number, maybe one that's divisible by 1, but not the other. Here, good. Maybe give it one that's divisible by 2, but not 5. And then finally, one that's not divisible by either one of them. Oh wait, sorry. Well, it is even. And we just display nothing. Okay. Get the number from the user. If, do it. If, do it. All right. Some Boolean operators, right? So if we want to enter an integer, want to tell if it's divisible by 2 and 3, that's where this and comes in. Is it divisible by either 2 or 3? Right? Is it divisible by 2 or 3, but not both? So an example. Some examples here. Oh wait, I have to do one thing first because otherwise it won't run. Okay. Run it. Enter an integer. Let's give it 2 and 3. Let's give it one that's 2 or 3. So let's give it one that's going to give us the true for everything. Okay. Divisible by 2 and 3, true. 2 or 3, true. 2 or 3, but not both, false, because it is divisible by both. Okay. Let's try to find one that's 4. Okay. Not divisible by both 2 and 3. It is divisible by 2 or 3. It is divisible by 2 or 3, but not both. So if we go the other way, 9, something divisible by 2 and 3, no. 2 or 3, yes. 2 or 3, but not both, yes. And then finally, let's give one that's not divisible by, it's going to give us false for everything. It's not even. It's not divisible by 3. It's not divisible by either one of them, and it's not by either one or not both. Okay? So this is some way that we can test some of these Boolean operators. I encourage you to look through this and come up with some of your own to try to figure out how you can use those Boolean operators. Okay. Notice here we had this Boolean expression, and we didn't require it to be inside of an if statement. It was just, we displayed it. We displayed false or true, right? We just displayed the result of this expression. We can do that. All right, moving on. Okay, here what we want to do is we want to create a random number. So this is a way to create a random number. Before the end of this series, before the end of this semester, you will see some other ways to create random numbers. Okay. So basically what this does is it says, okay, what's the current system time in milliseconds? And give me the remainder when I divide that by 10. Okay. So this kind of is like a random number, right? The current system time in milliseconds is kind of like a random number, right? What you guys will find out is there is no such thing as truly random in computing. It's all just based on system time, a lot of it, these random number generators. Okay. But for all practical purposes, if I were to run this code on my computer and hit it at the exact same time as you do on yours, we would still get different numbers. Okay. So here what we do is we take the current system time, milliseconds, and modulo 10. Here we multiply it by basically like a prime number to get a different number for number 2, and we modulo it by 10. Okay. So this is just in case between, the reason why we multiply this by 7 is in case this number and this number, in case these two lines of code are executed so close to each other that this would give me the same value each time. Okay. All right. So then I'm going to take in a number from the user, right? Well, I'm going to set myself up to get information from the user. I'm going to display a prompt. I'm going to ask them, what is number 1 plus number 2? Then I'm going to get their answer. Right? And I'm going to say number 1 plus number 2 equals whatever they said is it true or false? So I'm going to say, is it? So here I'm saying, I'm telling them this is what you entered. These are the two. And this is what you entered. And I'm going to tell you whether or not you were correct or not. So here we compile it and run it. All right, so what is 9 plus 3? Hopefully you guys all know this, right? Hopefully you know that it's 11. Wait, what? It's not 11? I was wrong. Oh, okay, let me try again. 7 plus 9. Give a correct answer this time. 16. True. So here, every time I run this, get this over and over again. Okay. Okay, I'm not sure what those comments are. All right, let's move on. All right. So that's an example of how we can use these Boolean operators, okay? All right, so one final example, no, two. I said I was gonna do the leap year one too, because I love the leap year one. All right, so here what we're going to do is we're going to, again, set ourselves up to take input from a user. We're going to ask them for their weight in pounds. So this is examples that are based out of an American system. Okay, we're going to enter our height in inches. We use the constant. We talked about these constants. A final double that tells me this is how many kilograms are in 1 pound, because I need to convert it to kilograms. Now I know you would want to be able to do this with kilograms and meters, right? I know, but this is not the way they did it. But think about how we might be able to modify this using an if statement where we could give the user an opportunity to tell us, do you want to use the metric system, or do you want to use that crazy, weird system they use in America where, you know, what 16 ounces in a pound or 12 inches in a foot, you know. Yeah. So, all right. So we find out what their weight in kilograms is. All right. Oh, what I was saying was we could use an if statement to give the user a choice of what unit of measure they want to use, whether they want to enter it in pounds and inches, or they want to enter it in kilograms and meters. Okay. All right. But either way, we need to get our weight in kilograms, we need to get our height in meters. And then we calculate what the BMI is. So hopefully, I don't know if you know BMI, body mass index. I cannot right now remember the Turkish word for this, the Turkish term. But if your BMI is basically, it's large, short people have high BMI and tall, skinny people have low BMI, basically. Okay. So if your BMI is low, then it's too low, you're considered underweight. If it's greater than or equal to 18.5, but less than 25, you're considered normal weight. Right? If you are greater than or equal to 25, but less than 30, you're considered overweight. And then finally, if you're above 30, you're considered obese, which is dangerous. It's not healthy, right? Results in lots of health issues like heart problems and stuff like that. Okay, so if we run it, so if I were to give it some information like what is my weight in pounds, I'll say let's give it even number 200. That's not my weight, by the way. All right. Height in inches. Let's see how I know how many feet I am. 6 times 12 is 72 inches. All right, so your BMI for a 6 foot even 200-pound person would be 27. So let's see what, in order to get to that height in inches of 72, let's see what my weight would need to be. What was the value? It's 27. So I'm close, right? I'm close. This person is close to that BMI. Let's see. Let's see. Would 190 do it? Oh, close, right? So let's see, maybe 185. Not quite. Okay, 180. And this person would then be normal, okay? One thing I do want to show is this debugger thing, right? So what we can do is we can set a breakpoint, click on the debugger, and it'll stop here. Now I can step over and tell it, okay, we'll enter that information. Okay. I'll step over. All right. So now it's going to say, okay, I want to get the height. Oh, wait, I need to hit enter. Okay. Step over. Step over. Notice it's putting all my variables in here for all these variables that I'm creating. So my weight in kilograms is this. My height in meters is this. So my BMI is this, right? And now it's going to print out BMI is. If BMI is less than 18.5, is it? No, so we're going to skip over that. Is it less than 25? Yes, so we're going to go in there, we're going to print normal, and we're done, right? We skipped right over it. Okay. One useful aspect of the debugger is you don't have to put a breakpoint here. If you know that there's a problem, maybe there's a problem somewhere after this line, you can put it here, press the debugger, and it won't stop. It won't make you have to click on this step over, step in stuff over here. We're just going to keep going up until it gets to then. Okay, now it's hit this line. It's done all this other lines of code, and now it's here. And now it's waiting. Okay. We can step over, print, and we're done. Okay. All right, one final example, the leap year example. So if we understand what a leap year is, so a leap year is this whole, the Earth does not go around the sun in 365 days exactly, right? You may have heard that it was 365.25, right? That's why we have a leap year about every 4 days, 4 years, about every 4 years. But that's actually not even true. It's actually something more like 2.422 or something. I don't know how they figured all that out. I don't know who was the first astronomer to figure this out. But basically what that means is that we don't just have a leap year every 4 years. Some years that are divisible by 4 are not leap years. So if a year is divisible by 4, baseline divisible by 4, it's going to be a leap year, unless if the year is divisible by 100, then it is not a leap year, unless if it's divisible by 400, it is a leap year. Oh, so confusing, right? So divisible by 4, yes, unless divisible by 100, no, unless it's divisible by 400, yes. Okay, so there's a couple different ways we could do this. We could have a whole series of if statements. If year is divisible by, we could have if it's divisible by 400, it is a leap year. Else, if it's divisible by 100, no, it's not a leap year. Else, if it's divisible by 4, it is a leap year. That would be a lot of if statements, right? What we could do instead is have this is leap year variable. And what we do is we say, okay, if it's divisible by 400, it's a leap year. Or if it's divisible by 4 and it's not divisible by 100. And then it becomes really simple. Then we just say year blank is a leap year question mark, true or false. Or we can use this as part of an if statement. If it is, print it is a leap year, otherwise print it's not. All right. So let me walk through how we might have done this otherwise. Okay, so I'm going to leave this out here. All right. I'm going to make a note here. I'm going to leave a note here because what we're going to do is we're going to go through an if statement method. Instead of using the Boolean variable, we will create okay. So we're going to create this file called leapyear2. Okay. All right. Make sure you always do this with your main method. Oh, I need to import the scanner. So the way that we could have done this was we could have said, I'm just going to copy this stuff here, because that will stay the same. So we're creating a scanner to get the year from the user, okay? So we could do this. We could say if year is divisible by 400, then we can right? We do that. And then we could say, okay, but if year is divisible by 100, I don't want to retype all that. So what I could do is I could just do this, and I could say is not. Right. So now, otherwise, it's divisible by 4. it is a leap year, else okay, so this should be it, right? Compile it. Somebody's got a comment. Ah, BMI. Yes. Okay. So if I run this, let's see, what year should we put? Hey, let's put in this year, right? 2020 is a leap year. Good. Right? Okay, so let's see. Let's see a couple of, let's see another example. What's in a, well, will next year be a leap year? Or let's see, with last year. Let's go back in time. Can we go back to 2019? Yeah, okay. Let's see, was 2019 a leap year? Not a leap year. Good. All right, let's check some of these other ones here. It's 400, 100. Let's see. Was 1900 a leap year? Whoa, wait. It's both? Not a leap year and it is a leap year? Did we do something wrong? Anyone? Anyone help me out here? Somebody? Yeah, we could, but we could check 2020. I think somebody's got a phone on them. What? Yeah, exactly. Okay, I think you guys are getting this. So the problem is that, so this might be a good, like a simple example where we might use the debugger. Okay, where we say we know there's a problem in here. So let's take a look. Because you guys are right about this whole else thing. Okay, so I'm going to enter 1900. Now it's going to stop here. Now I've got my year, I've got my set of if statements. Okay, I'm ready to go. Okay, so it was not divisible by 400, so it skipped over that. Good. It was divisible by 100. Good. So it should display is not a leap year because 1900 was not a leap year. Okay, so we display that. Now it's going to check. Oh, it's going to check this. Ah, yeah. Okay. So this is where, okay, the debugger helped us say, oh, it should not have gone in there, but why did it? We forgot an else. Okay. So then you might think, okay, well, there we go. Just put an else in there, and we're done. Right? Except we got one problem. Pilot first. Okay. So we run it, enter a year. If I put in a year like 2000, it should be a leap year. But we're going to get that same kind of problem again because we forgot the else here. Right? Same thing. Okay. All right. So let's check it now. One final run and go. $1900, not a leap year. Good. Not too bad. I didn't do no. 2000 is a leap year, and we're done. Okay, that's what we expected to see. That's so. Again, I want to make sure that as we end today, I'll go ahead and end a few minutes early. I want to make sure you guys understand. This is not the right answer for how to calculate a leap year. This is not the right answer for how to calculate a leap year. Both of these work. Both of these are valid solutions. Okay? This one requires more typing. It's not as optimized. It doesn't run as fast. It doesn't we don't notice it because it's so fast to us, to our human minds, that these run about the same speed, right? But this does have a lot more, if, else if, especially if a year like 2021, for example, would have to go through multiple if else's before it would get to its answer. Whereas here, right, this, right, one variable, one Boolean variable, we assign it a value, and we just say, is it a leap year or not? Okay. So how might we take the idea here of assigning a Boolean variable, and instead of just saying true or false on the end, what if instead we wanted to have it display something like this? How could we do that? Right? I'll leave that as a thought for you guys, for you to consider. How might I use something efficient like this, right, by assigning a variable instead of going through a series of if-else's, but yet get a result like this, where the year is a leap year, is not a leap year, instead of having to use this question mark true false display, right? I hope that, do you understand what I'm saying, where instead of saying 2000 is a leap year question mark, true or false, we say 2000 is not a leap year, or no, it was. No, 2000 is a leap year. That would be the difference of how the message would come through. So don't answer that on the chat unless you have already, but don't answer that on the chat. Think about that, about how you would use a Boolean variable to get this style of result, to get this type of thing. Okay. And hint, you could do that with a single system.out.println line. Okay. I want to go ahead and end there today because I think I've given you enough stuff to think about and enough stuff to do to kind of blow your mind a little bit. And so I don't want to give you too much more than you can handle in one day. So I wish that we could have gone through a good switch case example. Maybe we will next time, or maybe you can do that in lab. Maybe lab next week you can do that. Again, we won't be meeting next week because of the holiday, but you do have that assignment. And like I said, you have everything you need for this assignment. Okay, for the assignment, you now have everything you need to have access to be able to do the assignment. Okay. So unless there are any questions, Arjun, actually we went over that. It's in the recording. So if you rewatch this 3rd hour recording, then we went over the 4 examples. Okay. If there's no other questions, then we will end there for today. Okay. And I will see you on here in 2 weeks. Again, you have lab on Tuesday, but we will see you, for those of you who are in the lab. And other than that, we'll see you in 2 weeks. All right, have a good holiday, and thank you very much for attending.
See you.